Alright, I want to spend a little time talking about what we've been discussing lately, and this is looking at whether given situations are proportional or not proportional. Now, there's a few key things to look for depending on what you're given, so I'm going to kind of run through several of those examples. The first one we're going to look at is a graph. Now, graphs are really simple to determine proportionality because all you have to look for is does it go through the origin. You have to look for that 0, 0 ordered pair and see if our graph goes through it. So here I have two graphs. One that is proportional, one that's not proportional. Now if you can already see the origin, you may be able to tell which one is which. Now in this one I'm only looking at the first quadrant, so what I'm going to do is I'm going to kind of finish off my axes. So if my x continued this way and y continued this way, now you can see that my 0, 0 point would be right here, and this would be my origin. Now clearly the graph does not go through the origin, so this graph would be non-proportional. For the sake of time I'm not going to write it all out, but that would be non-proportional. If I come over to my other graph and do the same thing, continue my axes going out, here's my 0, 0 point, and look at this one, it does go through my origin right here, so this graph would be proportional. So with graphs, it's pretty simple to be able to tell proportional or non-proportional. You're looking for that origin point. Okay. Next example we're going to look at is some tables. Now with tables, there's a couple different things you can look. You can refer first off back to the graph, which is a great thing if you can see it. The graph goes through the origin, which means in a table, since these are just x and y points transferred on a table like we talked in our multiple representations, if I see 0, 0 on my table, that tells me I have the ordered pair 0, 0, which means it goes through the origin, therefore it is proportional. Now we could also check for a couple of other things. We could look at what is called or look for what is called our constant of proportionality. The constant of proportionality is that when you check your unit rates for each row, they come out to be the same. So this means if I did 800 over 40 and I divided that out, okay, I can get rid of those zeros at the end if I divide both by 10. Then I do 80 divided by 4, and that is going to give me 20. Okay, so let me check the second row. We want to see, is it the same thing? So I have 160 divided by 80. Again, I can divide both of them. Oh, excuse me, not 160, 1600. I was about to say, something's wrong here. So I have 1600. I cross out these N2 zeros. So let me go back a second. Right here, cross out my N2 zeros, and now I have 160 divided by 8. Well, I know 8 goes into 16 2 times and keep that 0. And so since both of these are 20, this means that my constant of proportionality is 20 because my unit rate stays the same. So when that unit rate is the same the whole way, that is going to mean that this is a proportional relationship. So this first one is proportional. Well, let's see what a non-proportional would look like. First off, since I see a 0 and it's not paired up with a 0, that tells me that this would be the point 0, 20. That's not the origin, so that's already keying me off saying that this probably isn't proportional. But let's check it with our unit rate because we may not always have that 0 point. So if I do 60 over 40, and it's always the y over x, sorry if I didn't say that earlier, to find the constant of proportionality, it's y over x. We're checking our unit rates. Okay, get rid of these zeros here when I divide by 10, and that is going to come out to be 1.5. Well, now let me check it with the next one. I do 100 over 80. Get rid of those zeros when I divide by 10. Now I divide 10 by 8. I know 8 goes in to 10 one time with 2 8ths left over, or that's going to be 1 1/4. Or again, if I go to my decimal point, 1.25. Now notice these numbers do not match. Since they don't match, this is not a proportional relationship. If it's proportional, we're going to see something like we did up here, where they're all the same. But since it's not, there is no constant of proportionality, therefore this graph is, or this table and situation is non-proportional. Tables are going to be an important one to understand because that's one that we will come back to often. Okay. Next, we'll look at an equation. Now, equations are some of the easiest ones to represent. Because what you have to look for on an equation is the relationship multiplicative, which means do I only have multiplication happening? If I have a constant, which means you're adding or subtracting anything, it is a non-proportional relationship. In this first one, I have a constant. The constant would be -5 because I'm doing more than just multiplying by 3. So this relationship is non-proportional. In my one over here, all I have is my 5x equals y. I don't have a constant that I can see because the constant is 0. So when the constant is 0, that's a proportional relationship. So if your equation looks something like this, that's going to be proportional. Now, it could also be negative. That would still be proportional. It could be a fraction, and that would still be proportional, as long as I'm not adding or subtracting. So some more non-proportional examples might be 2x plus 4 equals y, or even x minus 1 equals y. Okay? Anything that has this constant being added to it, added or subtracted to it, that's going to make it non-proportional. Lastly, I want to take a look at a scenario that we're going to see. Because in scenarios you can see the same way we have something being added or subtracted in an equation, we're looking for that same idea inside my scenario. So if we're looking at this first one, Alyssa rakes leaves for her neighbors. She charges $4 per hour, there's my multiplication to rake leaves, plus $7 to remove the leaves. Now when I see that plus charge, that's cueing me off saying, wait a second, if I wrote this out, there's my $4 per hour plus $7 to remove the leaves. There's my constant. So this situation is non-proportional. If I take a look at the one below, we say a fast train known as a bullet train travels at an average speed of 200 miles per hour, and that's it. So if I was going to write this equation, I have 200 miles per hour, where x is hours. This is a proportional equation or scenario because there's no constant. All I have is that multiplication. Okay, so just a few things to look for. That should cover all the different examples that we should see. So you should be pretty much experts now at proportional and non-proportional.